Hey there, it is I, Monaco, again, coming to you with another little solo video on how to manipulate and work with the reactants, products, and leftovers simulation at the very end of our unit pack on page, let's find it here. Yes, page 36. There's a simulation. So you can get there by copying and pasting the link, typing it out, or go to the fet.colorado.edu and type in reactants, products, leftovers. It's an HTML5, so it should work in most browsers. Now, what this simulation is about, it's about balancing equations and showing what happens when there's extra reactants. Because when you have a reaction, the ingredients, the reactants, have to combine in a very specific ratio. The mole coefficient tells you the ratio. And if you have extras, they're not going to react. They're going to remain left over. And if you don't have enough of one thing, you're not going to be able to produce as much product as you might originally think. So when you load up the simulation, you want to start with the sandwiches game. I'll use the cheese sandwiches to make a simple analogies. And it gives you a chemical equation for how to make a cheese sandwich. 2 slices of bread, 1 slice of cheese makes 1 sandwich. So let's see it. 2 slices of bread, 1 slice of cheese, 1 sandwich. Great. That's the basic chemical reaction. It's balanced right now. While this will automatically balance them for us, we might have something left over. Because if I had 2 slices of cheese, well, one of them is going to stay left over. It's not going to react because there's no bread to combine it with. If I added 2 more slices of bread, that slice of cheese can combine with the 2 slices of bread to make another sandwich. And if you look at the coefficients here, 4, 2, 2, we've actually just doubled what the basic reaction was. 2, 1, 1, so 4, 2, 2. So the idea is that, okay, a balanced equation can be used, and that's great, but if I have more reactants than I'm able to use, they're going to remain as not reacted, okay? That's a nice visual analogy with sandwiches, but what about molecules? Well, the only thing that's different about molecules is that we're using these particle models to show what's up. And this is the synthesis of water. 2 moles of hydrogen molecules combined with 1 mole of oxygen molecules to create 2 moles of H2O molecules. When I put 1 in there, I can see that I have 2 hydrogens and 2 oxygens, but I have no water yet. Why don't I have any water yet? Because I have to have 2 units of H2 to combine with 1 unit of O2 to make 2 H2O. So if I add 1 more H2 molecule, bink, boom, made some water molecules. If I had extra hydrogens, they're not going to react. They can't. There's no oxygen to react with. If I had extra oxygens, they're not going to react. They're going to stay by themselves because there's no hydrogen to react with. If there's 1 mole of H2 and 1 mole of O2 extra, can't react because you need 2 moles of H2 to combine with every O2. So no reaction is going to happen until I add a little bit more hydrogen. Boom. And here we are in the same scenario again, where I've actually doubled the amounts of reactants and products that are produced in an overall chemical reaction. In this case, there's no leftovers. If I kept adding more hydrogen, it's going to stay leftover until I add oxygen and hydrogen in the right ratio to get the product. Now, there's a game associated with this. 3 levels. Choose your level. Compete, try it out, see how you go. I put this out there for us that need another visual to help understand how to balance equations and how to use ratios. In the mole-mole ratio practice, all we're doing is using a conversion factor to predict how much product or reactant you're using the basic ratios for the mole coefficients. And in the balancing equations problems, all we're doing here is we're deciding what number goes on the blanks for the mole coefficients so that the reaction is overall balanced. Same amount of products and same amount of reactants as well. And so if the letter codes for the elements aren't doing it for you, just use your imagination. Create little particle models in your head for each different element that's involved. Polyatomic ions can be kept together, so make it a bigger, different kind of shape in your mind as you go through it. Use your imagination here. I taught particle models early on so that we could use that idea for many different skills throughout the year. When I'm balancing equations in my mind, I'm creating particle models for all of the different elements that are involved and changing the coefficients and ratios until it all matches up back and forth. And that's the whole point of it. So I hope this helps some of us who are having trouble with balancing equations and understanding limiting reactants. And that's what I got to say. Thanks. See ya.